Okay, I want to graph this and this. Now, for this first one, do you see it's a cubic? The second one is has a fourth power. So we have a third power and a fourth power. Now, isn't this going to be an odd function? Isn't this going to be an even function? Look at the front a value. Okay, what I want you to understand is you have y equals a x minus h to the n power plus k. That's what I want you to recognize right here. We have an a, which is the front number on both of these. You have an h, which is the parenthesis number right next to the x. You have a power, that could change depending on the problem. And you have k on the outside. Each a, h, and k, and the n, and the power, all do something special when graphing. All right? And you're going to see these effects happening in every single unit for every graph. They're very repetitious. So, taking a step back, we know for the first one my power is 3, and I know my a value is negative. That should tell you something. A power of 3 means it's odd, and it's negative. So what that means is my graph will look that on the right side, but up on the left side, and have some sort of turn or twist in between. Now, what does this problem over here say? I have a positive and a fourth, an even. So what that one means, it's going to go up on the right side, but since it's even, on the left side, it's also going to go up. So it's going to have that kind of look. So over here, we'll have this look. Over here, because of cubic, we're going to have this look. That's the first thing you want to think about. Okay, what's happening? How are they the same? How are they different? Next, we want to talk about HK. HK is a very important common thing. So what is HK here, and what is HK here? Well, for the first one, HK, that's your H, that's your K, but remember, it's the opposite of H. So my HK is really going to be 2, 5. Remember, it's always the opposite of the one next to the x. So for the next one, it's going to be the 3 and the negative 7, but the 3 is the opposite, so it's negative 3, negative 7. So those are our HK. Those are important points on the graph. So let's plot those. First one's 2, 5, so I could go 2, 5. There it is right there. And for the other one, it's negative 3, negative 7, so negative 3, negative 7 is right there. So those two dots are essential. They are the starting point of the graph. And my graph is going to look like this on the edge for the first one and this on the edge for the second one. So this point, let's sketch it. And it all depends on the front. This number right here, your a value of negative 2, helps you sketch. And it's kind of like a slope. What this number right here tells you is what the graph does when you go to the right one. So when I go right 1, it's telling me I'm going to go down 2. So I'm going to have a dot right there. So I'm going to have a dot right there because I went over 1 and I'm going to go down 2. And so my graph will look like that. But what does the other side look like? Well, doesn't the other side go up? Yeah. So we're going to use the same pattern, go the other direction with 2. So instead of going this way and down 2, we're going to go this way and up 2. So it's going to be right there. And then you have doesn't it look like a cubic with a twist? Do you see how we have a twist, a cubic, with a twist at 2, 5? Do you see how 2, 5 is where the twist went? You have your twist at 2, 5, your HK. And how far it twisted is the 2. The 2 tells you how vertically stretched it is. So you have this look, you have that coordinate, it all fits nice and neatly. So for this one, we have the beginning point, but it's going to go up in both directions, and this is how it goes up. So when we go 1 over, we're going to go up 3. So watch what happens. I'm going to go right up 3. You catch that? And you're going left up 3. So you're going to be right there. Now, why are we going this way? We're going to go up. Right? Because it says right there up 3. And on the left, are we also going to go up? Because of it tells us right there. So up 3. Doesn't that kind of look like a parabola? Yeah. It's not a parabola because it's a fourth power, but it looks a lot like it, almost identical. There are other effects that you're not seeing. But you look at the end behavior, this tells you you're going up 3 on each side. So fourth powers tend to have this look. Maybe it could be upside down if the front's negative. And cubics tend to have this look, depending on the direction by the a value. Tells you if you flip it and stuff. And what is HK? Well, isn't HK the vertex here and the spot where you twist here? And this is all going to keep building chapter by chapter with different new functions each time.